Hello, you are welcome to my class today. My name is Dr. Kingsley. Today in our class, I'll be taking you on Graham's law of diffusion. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of its density or the square root of its relative molecular mass at a constant temperature and pressure. Mathematically, it's saying that the rate of diffusion of a gas is inversely proportional to the square root of its density. Okay, so if we introduce a constant here, our R will become equals to the constant divided by root density. Now if I make constant the subject of formula, my K becomes equals to R square root of what? Density. Now since this is a constant, under different conditions, okay, of rate and density, we can see that our R1 square root of D1 will be equals to R2 square root of D2. If I take a constant R1 divided by R2, that is ratio. If I take a ratio of R1 divided by R2, it will be exactly equals to D2 divided by D1. So that means that R1 over R2 will be equals to square root of, okay, square root of D2 divided by square root of D1. Now, since this is having the same what? The same roots. This one is having roots and this is also having root. They can take a common root. That means R1 over R2 will be exactly equals to root what? D2 over D1. So this is what is the equation we use to calculate questions on rate of diffusion, Graham's law of diffusion. If we use molar mass to do this, we'll find out that rate of diffusion is also inversely proportional to square root of what? Molecular mass. The same thing, we will still get what? R1 over R2 is equals to square root of what? M2 over M1. Still the same thing. So the more the molar mass of a gas, the what? The slower the rate of diffusion. The lighter the gas, the higher the rate of diffusion. Now I want to give you this so that you always remember that the rate of diffusion of a gas, R1 over R2, will be equals to the length traveled by the gas. That is the distance traveled by the gas. Is also equals to the area, okay, of diffusion of the gas, which is also equals to the volume of the gas that is being diffused, which is what? Equals to time 2 over time 1. What does it mean from here? It simply means that what? The rate, the faster the rate of diffusion, okay, the more the length travel, the more the area of diffusion, the more the volume of diffusion. But if you come to time, it is now T2, not T1, but T2, which means what? The faster the rate of diffusion, the shorter the time taken for diffusion. And this has been proven to be equals to square root of D2 over D1, which is also equals to square root of what? M2 over M1. So please take note of this. You can use any of these two equations. Question can come from any of these two equations. So what I will do is that in my next class, I'll be giving you what? Questions on Graham's law of diffusion. Please, this class is very important for those that are in first year in the university and those who are preparing for WAEC, JAM, okay, NAPTEP, and so many other O-level exam. Thank you very much. Please subscribe now, okay, so that you can get to so many people. Also like and what, and put your questions in the comment section so that I can help you out. Thank you very much.